Good morning, students. How you all are? I hope you all are fine. You know that our country are facing many type of difficulties with corona. Okay, so stay home and be safe. And now, and be continue with your study with me. Okay. Now I am going to discuss about real number of class 10. In this chapter, we have to study about lemma, Euclid's division lemma, Euclid's division algorithm, fundamental theorem of arithmetic, SCF and LCM by prime factorization method. And also we have to study about proof of irrationality of irrational number. Okay, in this chapter we have to discuss about these all topics. I will discuss on each topic line by line, but firstly I want to introduce what is real number, which you have studied in your earlier classes. Okay, let's see. Okay, let's see what is real number. You all know that all numbers which really exist are real numbers. Okay, actually real number is collection of all rational number and irrational numbers. You all know that real number is collection of rational number and irrational number. Rational number, you also know, rational number is collection of fraction and integers. Okay, what is rational number? I will discuss about that every number which can be written in the form of p by q, where q is not equal to 0 and p and q are co-primes, or p or q are integers, are known as rational number. But also you know that rational number consists all fractions and also integers, and this integer contains negative integers with whole numbers. Okay, and this whole number consists 0 and natural number. Okay, आप लोग इस डायग्राम से समझ सकते हैं रियल नंबर क्या है. रियल नंबर कलेक्शन ऑफ रेशनल एंड इरेशनल नंबर. रेशनल नंबर कलेक्शन ऑफ फ्रैक्शन integers is a collection of negative integers with whole number is a collection of 0 with natural number. Let's start with natural number. You all know that all counting numbers are natural numbers, like 1 2 3 4 infinite. These also are natural numbers. When natural numbers combined with 0, then it result whole number. Okay, and when whole number combined with negative integers, like negative of natural number, then it make integers. Okay, or these integers with fractions makes rational number. Okay, understood? And irrational number, clearly the number which are not rational are irrational, meaning the number which cannot be written in the form of p by q, where q is not equal to 0 and p and q are integers, are irrational number. Okay, irrational number. And okay, you all see that what is real number. Okay, I am not going to write their definitions because you have studied in your earlier classes. Just go back in a study and see the definition of rational, irrational. Otherwise, you will see what am I saying. These all statements are also the definition of each topic. You may write it by listening carefully. Okay. Now I am going to start basic topic which we have to extra study in the real number for class 10. In this chapter, we have to study lemma. First topic is lemma. Lemma is nothing. It is, in other words, it means formula. Means lemma may be defined as any proven statement which is used to prove another statement is known as lemma. Lemma, it is a proven statement which is used to prove another statement. Okay, what do you see? It is a proven statement which is used to prove another statement. Just like formulas, ये एक प्रकार का प्रूवन स्टेटमेंट होता है जिसका यूज हम लोग दूसरे स्टेटमेंट या थ्योरम्स को प्रूव करने के लिए करते हैं. इट इज ओनली फॉर डिफिनेशन पॉइंट ऑफ व्यू. जस्ट मेमोराइज इट. ओके. नेक्स्ट टॉपिक इज यूक्लिड्स डिवीजन लेमा. यूक्लिड्स डिवीजन lemma. It is important topic for our chapter. Euclid division lemma. It is a lemma given by Euclid, and its definition is: for every two positive integer a and b, there exist two another whole numbers, unique whole numbers q and r, for which a is equal to bq plus r. It is the definition for Euclid division lemma. You may write it: for every two positive integers a and b, there exist two unique whole numbers q and r, such that a is equal to bq plus r, where 0 less than equal to r less than b, where a is known as dividend, b is known as divisor, q as quotient, and r as remainder. Okay. What is Euclid division lemma? For every two positive integers a and b, where a greater than b, there exist two unique whole number q and r, such that a is equal to bq plus r. And this remainder will be greater than equal to 0 and less than b, that is divisor. As you know that remainder is always less than divisor, and it is greater than or equal to 0. Okay, where a is equal to dividend, b is equal to divisor, q is equal to quotient, and r is equal to remainder. मीनिंग समझ ही रहे हो कि कोई भी दो नंबर हो, कोई भी दो पॉजिटिव इंटीजर्स हो, तो उसके लिए दो और पॉजिटिव इंटीजर्स q और r ऐसे एग्जिस्ट करेंगे कि a is equal to bq plus r. Meaning, as you know, dividend is equal to divisor into quotient plus remainder. आप लोग इसे पढ़े हैं पहले, उसी को स्टैंडर्ड फॉर्म में आपको इसमें दे दिया है और कुछ है नहीं. ठीक है. तो दिस इज यूक्लिड डिवीजन लेमा. ओके. नाउ I am going to discuss about next important topic, Euclid division algorithm. This is the formula, and Euclid division algorithm is the process to find HCF by using Euclid division lemma. तो आप ऐसे नहीं समझेंगे कि Euclid division lemma एक ही, Euclid division lemma और Euclid division algorithm दोनों सेम ही है. दोनों सेम नहीं है, दोनों अलग अलग डिफरेंट है. ठीक है. Euclid division lemma is the formula and Euclid division algorithm is the process. Okay, let's see. Okay. जैसे कि आप लोग देखें कि हम लोग यूक्लिड डिवीजन लेमा पढ़े, Now I am going to start topic Euclid division algorithm. Okay. Euclid's division algorithm. Euclid's division algorithm. Okay. Euclid division algorithm is only the process. Okay. Algorithm meaning process, or lemma meaning formula. Just like Euclid division algorithm, it is the process to find SCF of two integers a and b by using Euclid division lemma. It is the process to find HCF of two whole numbers a and b by using Euclid's division lemma. Okay. What is Euclid division algorithm? It is the process to find HCF of two whole numbers or two positive integers a and b by using Euclid division lemma. यूक्लिड डिवीजन लेमा का यूज करके दो होल नंबर्स ए और बी का जो एचसीएफ निकालने का पूरा प्रोसेस है उसे हम यूक्लिड डिवीजन एल्गोरिथम कहते हैं. ओके, अंडरस्टूड. अब बस सवाल आती है कि हाउ कैन वी फाइंड एचसीएफ बाय यूजिंग यूक्लिड डिवीजन लेमा. मींस यूक्लिड डिवीजन एल्गोरिथम का यूज करके हम दो नंबर्स का एचसीएफ कैसे निकालेंगे. ठीक है, तो इसके लिए कंसेप्ट है. देखिए वन बाय वन हम इसको बताते हैं एक क्वेश्चन पे. ओके, तो पहले लिखते हैं व्हाट इज यूक्लिड डिवीजन एल्गोरिथम. To find what is the process to find LCF of two numbers by using Euclid division algorithm. Means method of finding LCF of two number A and B where A greater than B by Euclid's division algorithm. Okay, I am going to write each topic line by line. Just pause it. Okay, method of finding HCF of two numbers a and b, a greater than b by Euclid's division algorithm. These are the following steps which we have to use to find the HCF of two numbers by using Euclid division algorithm or lemma. Let's see. Firstly, we have to write a and b by using Euclid division lemma as a is equal to bq plus r1. Okay, पहले हमको a और b को Euclid division lemma का फॉर्मूला a is equal to bq plus r1 के फॉर्म में लिखना है. ठीक है, if r1 is equal to 0 then b is the HCF of ab. If in this expression, in this lemma, remainder becomes 0, then in that case, divisor of that expression will be HCF of both two numbers a and b. But another question is if remainder not equal to 0. That means if in this process, in this lemma, remainder not comes 0, then write b and r1, meaning divisor b and remainder r1 in the form b is equal to r1s plus r2. मीनिंग जब रिमाइंडर 0 ना हो तो उस केस में आप उस एक्सप्रेशन का डिवीजर b को डिविडेंड लेंगे और उसके रिमाइंडर r1 को डिवीजर लेकर आगे बढ़ेंगे. ओके, उस केस में भी कुछ क्वोशिएंट आएगा और कुछ रिमाइंडर आएगा. अगर इस केस में रिमाइंडर 0 आता है तो इस केस का जो डिवीजर है यानी r1 आपका एचसीएफ होगा. लेकिन ये भी सवाल आता है कि जब रिमाइंडर तब भी 0 ना आए तब हमको यही प्रोसेस तब तक यूज करना है जब तक रिमाइंडर 0 ना आ जाए. ओके, सो और जिस एक्सप्रेशन में रिमाइंडर 0 आएगा वो उसी एक्सप्रेशन का आपको डिवीजर जो होगा वही उसका रिक्वायर्ड एचसीएफ होगा. यू ऑल नो दैट if R2 is equal to 0, then use this process till remainder becomes 0. At that time, divisor of that expression will be required HCF. Means we don't have to stop this process until we will find remainder 0. The expression in which remainder becomes 0 will be HCF given expression. In that case, divisor of that expression will be required HCF. Okay, let's see one problem which I am going to solve, by which we will understand it easily. Okay, find HCF of following numbers using Euclid division algorithm. These are two numbers 10 and 22. इसका भी निकालना है. Another question is 16 and 28. हम लोग दोनों का 1 by 1 देखेंगे और कैसे हम इस प्रोसेस का यूज करके इसका HCF निकालते हैं, ध्यान दीजिए. ओके, solution portion. Firstly, we have to write here 22 greater than 10. Okay, therefore greater portion will be A and a smaller portion will be 10. Therefore, by Euclid's division lemma, each dividend will be written in the form of division into quotient plus remainder. As you know that here A 22 is the dividend and divisor is the 10. Divide 22 by 10, which quotient comes and remainder write in the form of A is equal to B plus R. Okay, तो here हो जाएगा 22 is equal to 10 into 2 plus 2 हो जाएगा. कैसे, ध्यान दीजिए, 10 से 22 को डिवाइड किए तो quotient 2. ओके, and remainder comes out 2. तो write dividend into divisor into quotient plus remainder. What you have seen here? Here remainder is equal to 2, not equal to 0. What am I saying? If remainder not becomes 0, then use B and R1 in the form of B is equal to R1 plus R1s plus R2. मतलब इस केस का रिमाइंडर तो 0 हुआ नहीं, तो इस केस का जो डिवीजर है यानी 10 और जो रिमाइंडर आया 2, वो दोनों डिविडेंड और डिवीजर बन जाएंगे. यानी यहाँ पे अब डिवीजर नेक्स्ट प्रोसेस में बनेगा 10 डिविडेंड और रिमाइंडर 2, ये रिमाइंडर 2 डिवीजर. अब 2 डिवीजर 10 डिविडेंड डिवाइडेड, 10 को 2 से डिवाइड करेंगे, 10 को 2 से डिवाइड करेंगे 5 टाइम्स 10, रिमाइंडर बिकम्स 0. Meaning you can write it 10 is equal to 2 into 5 plus remainder 0. तो लिखेंगे here R is equal to 0 and you have already studied that the expression in which remainder becomes 0, then at that time the divisor of that expression will be HCF of required numbers. Okay, तो यहाँ पे रिमाइंडर 0 हो चुका है, तो इस एक्सप्रेशन, कौन सा एक्सप्रेशन, ये वाला एक्सप्रेशन जो इसके जस्ट ऊपर है जिसपे रिमाइंडर 0 आया है, उसका जो डिवीजन पोर्शन है, डिवीजर कौन है 2 है, तो यही 2 इन दोनों नंबर्स का HCF होगा. ठीक है, तो लिख सकते हैं therefore HCF of 10 and 22 is equal to what? These 2. Understood? अगर यहीं पे रिमाइंडर 0 नहीं आता तो फिर से हम आगे बढ़ते, क्या करते, उस पे फिर से डिवीजर को डिविडेंड बनाते और रिमाइंडर जो आता उसको हम लोग डिवीजर बनाते. तो स्टूडेंट, यू हैव ऑलरेडी नो हाउ कैन वी सॉल्व दिस टाइप ऑफ प्रॉब्लम्स. ओके, लेट्स सी नेक्स्ट प्रॉब्लम. ओके, ओके, नाउ आई एम गोइंग टू सॉल्व द सेकंड प्रॉब्लम 16 and 28 by Euclid's division algorithm. Let's see how. Same process. Firstly we have to check which number is greater. Clearly 28 greater than, here 28 greater than 16, therefore A is equal to 28 and B is equal to 16, and write in the form of by Euclid's division lemma. और हाँ, आप लोग यूक्लिड डिवीजन लेमा के जगह पे यूक्लिड डिवीजन एल्गोरिथम नहीं लिखेंगे. यूक्लिड डिवीजन एल्गोरिथम आपको पहले ही बताया, इट इज द प्रोसेस नॉट द फॉर्मूला. वी आर यूजिंग दिस फॉर्मूला टू फाइंड द HCF. ओके, तो दिस होल प्रोसेस टू फाइंड HCF इज द एल्गोरिथम, एंड सो वी डोंट हैव टू राइट यूक्लिड डिवीजन एल्गोरिथम हियर. ओके, वी हैव टू राइट यूक्लिड डिवीजन लेमा. लेट्स सी therefore 28 डिवीजन 22 डिवाइड करते हैं क्लियरली 28 को 22 से डिवाइड करेंगे क्वोशिएंट 1 आएगा और रिमाइंडर 6 आएगा तो लिख देंगे डिविडेंड इक्वल टू डिवीजन इनटू क्वोशिएंट प्लस रिमाइंडर 6 यहाँ पे रिमाइंडर 0 हुआ नहीं हुआ तो क्लियरली हियर r इक्वल टू 6 नॉट इक्वल टू 0 इन दैट केस नेक्स्ट ये डिविडेंड हो जाएगा और रिमाइंडर जो है वो डिवाइजर हो जाएगा ठीक है अब फिर ना 22 को हम लोग 6 से डिवाइड करेंगे तो 6 डिवाइडेड 22 क्लियरली क्वोशिएंट विल बी 3 18 एंड रिमाइंडर बिकम्स 4 मीनिंग यू कैन राइट 22 इक्वल टू 6 इंटू 3 प्लस 4 आप यहाँ भी देख रहे हो रिमाइंडर नॉट इक्वल टू 0 तो हम आगे फिर से बढ़ेंगे तो हियर r इक्वल टू 4 नॉट इक्वल टू 0 then use the next process similarly this 6 becomes dividend and this remainder becomes divisor divide 6 by 4 quotient will be 1 or remainder will be 2 okay you can see here 4 6 1 4 2 and out again r is equal to 2 not equal to 0 okay again this divisor becomes dividend and this remainder becomes divisor divide it 2 से डिवाइड करेंगे 2 टाइम्स और रिमाइंडर क्या आएगा 0 तो therefore here r is equal to 0 so divisor of this expression will be required HCF and we have to do this process until we get remainder 0 okay here r is equal to 0 therefore HCF of which number 16 and 28 will be 2 okay and it out no plane okay students you see what is Euclidean division algorithm and how can we solve to find HCF by Euclidean division algorithm you can easily solve this type of problems by Euclidean division algorithm and if you have any doubt of that type of problems then you may contact on my number which you all know 95763495337 okay now in next session I will discuss many type of another problems dependent on Euclidean division algorithm thank you